Hi everyone, my name is Elizabeth and I will be taking you today's session. We'll be discussing important things to know about networking in AWS. It's going to be a very straightforward focused session today. We won't be coding, we won't be writing any infrastructure as code or anything related. It's going to be a solid discussion and learning like tips, best practices, and setting up your basic networking in AWS. I say basic because the things we're discussing today, you don't need to be a network engineer to know them. You don't need to have gone through like special certifications to be able to set them up, but it's just about doing things properly in your AWS environment. Okay, so we can get started. This is not the page I'm going to be starting with. I think firstly I'm going to be starting with just discussing like the AWS global infrastructure again, and then you are going to continue from here because it's important to like revise that. If you've not been with us, it's not a special session that you need everything that you've done before, so you can just jump right in today. The AWS global infrastructure we're going to be talking about is the same one you know everywhere. I don't know if I can put it up here. AWS global architecture. I think it was somewhere here. Yeah. So we know about the regions and the availability zones. If you don't, the AWS regions are like the main locations that you will see in AWS environments when we're talking of the different regions you can deploy infrastructure in. And it's really separately governed because some resources or some services are available in some regions, some are not. Some prices are different in some regions, some are not. But it's important to know which region you're going to be working in because everything we're going to be working on, the availability zones, the subnets, everything is built on the region, then it's built on the availability zone, and then so we can't talk about the networking without talking about the global infrastructure. And I wanted us to say this first because when you're planning your network, when you're planning the topology of your network, knowing where you place your resources in terms of region, availability zones, directly impacts or directly affects your latency, how fast you can get responses or connections between your services, or even if you can access them at all. It greatly impacts it. So you can't skip this and just jump right into networking. Yes. And I think I'm going to be opening my AWS account and we're going to be looking in that account as we talk and as we walk through this. The AWS console is going to be console.aws.amazon.com. I already have an account. If you don't have an AWS account, you can open one and follow along. If you don't, that's fine. You can just watch what I'm showing you. We're not going to be deploying any infrastructure, so it's just like show and tell kind of. Yeah, I have a dev account user set up here and the password. Okay, so this is the console, AWS console, and in this navigation bar at the top, you will see my account ID at the rightmost part of it. If you drop down, you can see more details about the user that is logged in, yes. But right next to it, to the left of it, you see this region. I'm currently in Europe, Frankfurt region. If I click it, you can see all the other regions that I have available to me. If you scroll down, you will see here there's a note that says there are 15 regions that are not enabled for this account. I can go ahead and enable it in my root account or something, but this is what I have available to me right now. And I can deploy resources in any of these regions. If I deploy my resources in North Virginia, that's US East 1, I won't be able to work on them from inside Ohio, like US East 2. So if you've ever listened to any of my sessions before, you will see that I've mentioned at some point, if you can't find the resource you deployed in your environment, check to make sure that you are in the right region. So if I deploy something here, I won't find it in the other region. So it's important to know where you're deploying your stuff. And I'm in Frankfurt, as we know. And here we're going to be talking about the AWS networking, which is centered around the VPC service in AWS. VPC stands for Virtual Private Cloud. I think that's what it is. I hope I remember correctly. But yes, Virtual Private Cloud, and there are a lot of different parts, components for the Virtual Private Cloud that you would need to set up for everything you are using to work well. If you look to the left, like in this navigation bar on the left, there are a lot of drop downs and a lot of links there that you can click. You would not need to use everything. Even if you work in AWS for like the next 10 years, you may never have to use maybe Lattice services or something. But there are some basic ones that you would definitely have to use, and that's where our focus is going to lie on today. We're going to look at them, we're going to learn best things to do with them, best ways to use them, and things not to do with them. Yes. So I'll just quickly run through and mention the ones we'll probably be talking on. So yes, we have our VPCs. I have only one VPC here. And you can see this VPC has a lot of different, let's say, properties to it. We're going to be looking at them. But I will tell you, this is my default VPC. Every AWS account that is created, I think they wrote it somewhere, that's created after a particular date. I'm not sure if I saw it somewhere. But the point is, okay, yeah, every account that is created after December 4, 2013 comes with a default VPC. So if your account was created before then, you probably didn't have a default VPC, which I don't expect. I mean, if you created 2013, you're probably not going to be in my session today. But every account, just say every account has a default VPC. And you can start working with that VPC like right away when you open your AWS account. Now, best practice I would tell you is do not work with the default VPC. I know you wonder why are they giving us default VPC if you advise us not to work with default VPC. The thing is, when you work with the default VPC in AWS environment, in the future, it can prove difficult for you to do some things that you want to do. Okay, so I'm talking of maybe things like VPC pairing, like trying to connect two VPCs together, which is part of AWS networking. If both of you are using your default VPCs in this account and you want to connect those VPCs, you can't pair the default VPC. It's usually advised when you want to create your VPC. You can create your VPC in your account. So create your own VPC and work with it instead. That eliminates all the issues that you may encounter while trying to use default VPC. There are no issues by itself, but when you want to do more complex, complicated thing down the line, it can become a restriction for you, like because you were using only the default VPC. And then you would need to, redeploy your resources in another VPC, and all the IP addresses are going to have to change, because when you change VPC, which is what we're going to be talking about, yeah, like why the whole net IP addresses and everything with the VPC. But when you define your VPC, it's giving like a specific number of IP addresses available in that virtual private cloud, and your resources can only use the IP addresses that are available there. But if you're moving them somewhere else, they are leaving that space and their IP addresses, you're going to have to drop it, and you're going to have to redeploy them, give them new IP addresses and all that, blah, 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 in the new environment. So it can prove complicated. Do not use your default VPCs. That's just one rule I want to say here. That's what all my talking is about. Don't use the default VPCs if you can avoid it. But for tutorials, for simple things like this, that we already know exactly what we want to deploy and try out, and then we're putting it down, of course, that's fine. But yeah. Okay, now let's get started with this, how Amazon VPC works. I shared these links in the channel. There's a WhatsApp channel. I shared it there, so you may have had time to look through it. If you haven't, it's fine. We would try our best to cover the important things here. How Amazon VPC works. So here we are looking at a VPC. I'm going to select this so that we can see the detail of this VPC. Yes. Now, the most important thing is this, I would say. Okay, where do I go from here? So, the IP addresses in your VPC, remember I said when you provision your VPC, you say, this is the IP addresses that I want in my VPC. And AWS works with that. We have the IPv4 CIDR block, and we have the IPv6. These are two different kind of IP addressing. I'm not going to go into detail in the difference between IPv4 and IPv6, but IPv6 is the newer one and is being pushed to be widely adopted. And maybe sometime in the future, IPv4 may not be, will it ever be not supported? I don't know. But the point is, IPv6 is still newer and not yet fully adopted in everywhere in the world. So sometimes you may decide, okay, well, we're using IPv4 IP addresses in our VPC, or you can say, oh, I want to use both IPv4 and IPv6 addresses in my VPC. The IPv4 addresses look like this. IPv6 addresses, they look different. Let me see if I can find IPv6 addresses to show you. 6 address. It looks different. You can see it looks something like this. It's way longer and it looks like this. It looks like this. It has 1, 2, 3, 4, 5, 6, 7. It has it's different. And whereas the IPv4 address looks like this. This one has just 4 parts, just 4 octets. And that's what you see generally all over the internet in IP addresses. You see this. Now, we can't talk about networking without talking about IP address, because IP address is what identifies any device, any location, any destination or source on the internet. So your computer talking to another computer, or you trying to access Google or anything, all the addresses you are seeing in the end all translate to IP addresses behind the scene. So any form of communication, any form of transfer or transmission of information has to do with your IP addresses behind the scene. Maybe it's IPv4 address or it's IPv6 address, whatever. It just has to be an IP address in the end. Yes. So back to where we were. Yes. So I would say this is the most important thing in your VPC, because like when you are creating your VPC, you may decide, oh, I'm going to use this subnet or this. You can define a lot of things in the console when you're creating your VPC. And when you are creating it via your CLI command line, you don't get to define all those things. Like you have to manually attach them later or change them whichever way you want. But something that is always constant is you have to specify the CIDR block range for your VPC. This is the CIDR block range. I will try to interpret this as best as I can without getting too technical or mathematical about it. But what this does is it calculates the exact number of IP addresses that you want to provision in your VPC. So this starts from 172.31.0.0. That's where it starts from. And then it counts all the IP addresses after that up to the amount that you have decided is going to be available in your VPC. and those are the IP addresses that it is going to be dishing out to your resources as you are deploying them. In your VPC, every resource that you deploy there is going to have an IP address from this range. It's never going to be out of this range. It's going to be 172.31 point something 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 based on what you have already put here. Now, this /16 after it is what determines the size. Remember I said this first IP address that is here is the starting point, and the /16 behind it is what calculates the size. We call that the mask. That's the mask, the CIDR mask. So /16, the way it is calculated is 2 raised to power 32 minus 2 raised to power 16 gives you the exact amount that you want. How do I calculate it? It's in thousands, but let's see if we can. And there are actually CIDR block like calculator, a subnet calculator or whatever. Like you put the this mask in, it's going to tell you the exact amount of IP addresses you're going to generate. Or you can put in the amount of IP addresses you need, and it will kind of give you a mask that would fit that provision. A lot of people go ahead creating AWS environments, setting up VPC networking in AWS without being cautious of the amount of IP addresses they actually need. It's important for you to know what you're trying to provision in your environment before you go in. I know that there are ways to attach like additional CIDR block, like maybe to provision extra IP addresses when you run out, but it could have been better. Yeah, like it could have been better without you having to break down the CIDR blocks into different parts that okay, I'm trying to provision this amount of, maybe I'm building a very big solution and I'm going to have like, I don't know, 100 EC2 instances and 1,000 pods in my Kubernetes cluster, blah, 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 and they need this amount of IP addresses. When you know already, like, estimate, okay, plus my DB, my database server, okay, plus this one, you have an idea, and then you add extras. You're able to know that I need at least this amount. It must not go below this, and you are set. So now, this one that we have here, if I want to, let me show you, there should be a calculator somewhere, I think. It says CIDR calculator. There's a lot of them. Like I said, it depends on whatever you need. If you ever need to, I just search and I pick the first one. So here you can see, you put the CIDR block, and when you calculate it, it will give you all the. So here we have, from this one, we have, let me see, the first IP. I told you the first IP is the first part of your CIDR block, and then this mask says 24. So we should have this is showing just the IP range. It's showing just the IP range. It's not showing us the number, but we can get the number. This one, it says like we're going to have from 10.0.0.00 all the way to 10.0.0.255. So that's going to be 10.0.0.0.1, 10.0.0.2, 10.0.0.3, 10.0.0.4, like that, all the way to 255. And those are all the IP addresses you're going to have. So this should be 256 IP addresses. Okay, yeah, I think I saw it here. Yeah, so this is it, the total host, 256. The one we are trying to provision here is mask /16. So if we copy this, we'll see like the exact amount that's going to be here. It's going to be bigger than 256. What we're going to have is 65,536 IP addresses in our VPC. Yes. So you can see our first IP address is also 172.31.0.0, and our last IP address is 172.31.255.255. That gives all the way from that down to the last IP. And we have over 65,000. That's a lot. It might seem like a lot for this. It's a lot for whatever we want to do, but it may not be a lot for a really large scale kind of business or something. But yeah, we can continue from this. I think you understand very well this IP address thing and how to, decide the CIDR block you are going to be using to create your VPC, because it may look like just putting random numbers there, but it's not random numbers. Yes, it's not random numbers. Most of us tend to use 10.0.0.0 to start, and then you can put your CIDR block from there. But now where it gets interesting is that this VPC is the whole isolated space in your AWS environment where you want to do things. You can have more than one VPC in your AWS environment. So you can use a VPC to isolate everything you're doing regarding something, and you put other things in another VPC, yes. Now, you provision all these IP addresses in your VPC. Within your VPC, there's still a lot of networking things to do, where you're still going to need to, what we call it, cut this VPC, like this VPC CIDR, your VPC CIDR block. These IP addresses you have, you're still going to need to share it within sub-networks in your VPC. So you have your main VPC network, and then you can still have isolated VPC sub-networks. That's what we call subnets in AWS. So here you'll see your VPC. I don't know if you can see my cursor. And then in the subnets, we don't have any subnets right now, but we will need to create the subnets inside our VPC where we want to put our resources. Yes. We're going to be going further beyond VPC. When we're talking something, we're going to be going further beyond VPC. So now we can see this is the default VPC and route tables. Okay, another thing I want us to talk about, route tables. So we have the main route table in our VPC as this one. This is the main route table in our VPC. Your VPC will always have a main route table, and a route table in AWS networking is like a list of instructions on where to route certain network requests or network transfer stuff. It's just showing, okay, if you're looking for this destination, go to this place. That's what the route table does. It's just a list of routes, like, okay, this is going here, this is going there. You can see here 0.0.0.0/0, which stands for anywhere. Anytime you see this in networking, it means the entire internet, like, it's going anywhere. So this, as you can see, it's basically every kind of request is going to our internet gateway. Now, your VPC, remember, virtual private cloud, a VPC in AWS is an isolated environment. It's an isolated environment that everything you do within it stays within the VPC. There's no internal or external. If it's looking for this address to anywhere, it's going to find it within your VPC. If it does not find it, that's gone. So if you want it to be able to go outside your VPC and search outside your VPC, you need to direct every request that is like external. You want to direct it to an internet gateway that's going to be your access to outside. An internet gateway is one of the types of gateways you have in AWS networking that allows interaction with the entire internet, like with the public. So we have an internet gateway here. You may not have an internet gateway. If you don't need anything to do with internet, you can decide I want this fully isolated because it's better privacy, better security if you don't have connection to the internet. So when you don't need connection to the internet, make sure you don't add a connection to internet. I know a lot of us like to do things just in case I'll need it later. You don't do that in networking. You don't do that in security. You don't do that in you don't do that in you don't do that in program. You don't do that in computer science in general. Whatever you are doing should have a reason, a justifiable, valid reason. Don't do things just in case. Don't leave things open just in case. Don't deploy resources just in case. Even if security is not your issue, the cost will tell you differently. So we have an internet gateway here, and it's basically a gateway to the internet. Yes. So that's one of the things in our route table. Remember, we're looking at the main route table in our VPC, and what it says is every request or every what do you call this thing? Every let me just say every request. This is another word I wanted to use. Every request with the destination that is in this mask, please direct it to the internet gateway. And you know what? The internet gateway knows what to do with requests that comes to it. It sends it out to the internet. And any request that is coming to 172 points. Does this look familiar to you? This is the CIDR block for our VPC. Yes. So this says all the IP addresses in this VPC. Every IP address in this VPC should go to local. Local basically means check internally. We have it somewhere here, directed locally. Now, you'll be wondering that this 0.0.0.0/0 should include all these IP addresses in our VPC also. Like this anywhere should also include everything we have here. True. But the way the route table works is it matches the most specific destination and uses it instead. Like this request may match multiple entries in our route table, but to pick the one that is most specific, like the one that is most accurate, the smallest, the most pinpointed, exactly, like that's the one that is going to pick and use. So even if I have another one that says 172.31.0.1, like exact destination, it's going to pick that one over this one because that's more specific than the larger block. So that's how it prioritizes which routes to use in your route table. Yes. And I would not be going deeper into route propagation and all that because that gets more complex. We're going to be talking about more things like VPC pairing, we're talking about transit gateways and other connections like connecting your VPCs beyond each other. But currently, this route table is what we have. And a route table is not only, let me see, it's not only going to be like, okay, your main route table for VPC. There are other things that we use route table for too, which we'll be looking at. I hope you have the time. But yes, so this kind of view is what you have when you open your VPC. When you have subnets set up, you have route tables connected to subnets set up and connections like the internet gateway. You get to see everything visually, how they are plugged into each other. We don't have so much set up in our VPC yet, but I'll show you where that is so that you can always inspect here in your resource map. I don't know if you can see this. In your resource map, we have a VPC. We don't have any subnet yet. And then we have this route table in our VPC. You can see it is connected to internet gateway because there's a route there that connects it to the internet gateway. The point is you can have a bird's eye view of what is going on in your VPC with this resource map. Okay, now we mentioned the main route table in our VPC, but you can see that here it's not connected to this VPC. It's not. Why is that? We have a main route table in the VPC, yes, but what it just means is that it's going to be like the route table that all your subnets that you create use if you don't attach them to another route table. Like you can attach the same route table to as many subnets as you want, but you can only have one route table for a subnet. Okay, so you can have different subnets in your VPC that you use their own route table or different route table. You don't want them to route things the same way. Like in this subnet, like remember I said subnet is like a subnetwork of your VPC. Like you've created a smaller network inside your VPC. In this subnet, I want it to direct all the things that are going to the internet to another subnet. That's an example. I don't want it to go to internet gate. I want it to go to somewhere else. Like you can have specific routes in your route table for a subnet. So that's why it's easier for you to attach it to a subnet or detach it or whichever way you want to do it. Basically, yeah. Okay, so that's what route tables are. And when you create a subnet and you don't create a what they call this thing, a special route table, it's going to just use the main route table. And we can move down here. So we've been talking about subnet, yes, and you can see here written is it's a range of IP addresses in your VPC, just a part of all the IP addresses you have in your VPC, all the things that you want to do with these IP addresses is this smaller network in your VPC. So we already talked about default and non-default VPCs. Configure your own VPC as you want, and it's not a default VPC. Okay, we've talked about route tables, and you can try creating route tables if you want, or change the routes on your existing route table. It's possible to add more routes or edit existing ones. And I mentioned accessing the internet using your internet gateway. Yeah. Okay. This one from here down, it gets much complicated, and I wouldn't want us to touch on that because we're not going to be building anything that has to do with that anytime soon. But you should know that there are ways to connect your VPC, your isolated environment in AWS, directly to on-premise network on your, right in your home. Or, no one really connects. Let me say no one. I've not met somebody that tried to connect AWS resources to their own house via VPN, but it's very common in a workplace, trying to connect the AWS network to your workplace network via VPN. So what that means is that all the interaction between both networks, both environments, are going through a secure network, like via the VPN. It's not going through the public internet, so it's secure. It's like end-to-end kind of connection. And there are ways to do that, but we won't be touching on that. This is connecting your VPC with other networks. You must have heard me mention VPC peering, transit gateways. If you're interested, you can try looking into them. We'll be touching it way later down because I wouldn't want to just be teaching stuff that we're not using, yes? So we're focusing on the basic ones now. But when you want to connect two VPCs, remember I said your VPC, everything interacts only within itself. If you want to route something out, you have to route it through your route table and all. But if you don't want it to go to the internet like anywhere, but you want this VPC to be connected, you can connect two VPCs directly like that, or more VPCs directly in AWS without having to go through the public internet. That's what we were talking of, VPC peering, transit gateway. There are two different ways to do that. but they also have their uses, the ways to do them, and when you should use which one over the other. You get? Like in VPC pairing, I'll just tell you this. In VPC pairing, you have to make sure that the IP addresses in this VPC are different from the IP addresses in the other VPC. Like they have to be totally different. You cannot have overlapping VPC cider block ranges when you're doing VPC pairing. So that's why sometimes people pick transit gateway over VPC pairing, but transit gateways also have their own costs. Like it's there's a lot of different things that you need to know about them, which we won't be going into today. But it's interesting for you. You can also look into it if it's interesting for you. And I'll be stopping this particular page, I would say here. You can go look more into it, but yeah, I think this is a lot about how Amazon VPC works. Now, we're looking at not this one. Yes, okay, I've mentioned subnets. There's something I want to do before we come to this one. I want to talk on the security groups. If you have been deploying stuff with us, you see that we have used security group in the past, but you may not have had time to explore it or know what it really does. If you are working with us for the first time, it's also fine. I'm going to explain it now. So, security groups. Okay, I'm going to go down here. Security groups. So, remember I said VPCs. A VPC, you have all your IP addresses that you've decided, like, okay, this is the range I want for my VPC. These are the IP addresses I want in my cider block. Fine. Then you have a subnet inside your VPC that you create, and you say, out of all the IP addresses that I have decided to make in my VPC, I want this smaller part of it to be allocated to this subnet. I want another subnet also to have another part of it. Like you can have a lot of subnets inside your VPC, and you will just be cutting part of your VPC cider block range for them, like sharing out your IP addresses to the different subnets small. So you can look at it as per, okay, inside my subnet now I have IP addresses that I want to use for this subnet, and inside that subnet the resources you put there will only use the IP addresses that you have inside this small subnet, the IP addresses inside this other small subnet, like that. So it's a way to isolate even more some resources inside your VPC. Now, using security groups is also for controlling access. Everything, you see, we've been isolated. You've been wondering why so many different levels. Okay. It's not something you'll be able to just explain once and for all, yes, but there are some communications that you want to happen between your resources that need to be controlled. Okay, yes, I want this thing to be secure and safe from everything, but I want to allow only some people to reach here. I want to allow only this particular type of request to reach here. When you get here, I only want this one to continue. Like, there are different levels that you can place that isolation in your resource. And that's why if you're able to do this very well, it can make a difference for your experience with your entire project. It's not good enough for you to just open everything to everywhere. That's the solution that most people do when you're getting into the cloud. Some people they get by without having any issues, but some people have horror stories to share where they get hacked. People use their servers to, I don't know, mine Bitcoin or something, and everything was just open. Because you want things to work, you open everything up to everywhere and everything is working. No, don't do that. So if you understand at which level you need to allow what through it, then it can make a lot of difference for your experience with the cloud. Now, security groups. Security groups would be inside your VPC. security groups, you are not assigning IP addresses to a security group or anything like that. Security group is just to limit access. That is not provisioning. It's not a network. It's not anything like that. So a security group, I would show you. I think, let me see if we have any security group created here. A security group has rules that you put there. Okay, we have a security group here. You have rules that you set in your security group that you use. You have your inbound rules, like rules for whatever is coming into your security group, and outbound rules for whatever is going out. So this one says that this inbound rule, let me see, it allows all traffic, all protocol on all port ranges. This one allows everything in. So imagine I'm using default everything. I put the security group on my resource and then everything has access to it. That's not what I want. On all ports, even my port 22, even my no, no. You can create more rules, you can edit rules in your security group. But the point is, a security group protects resources in your VPC. So what happens is, when you create a resource in your VPC, like maybe you create a server or you create a cluster, something you create, you can attach a security group to that resource. That this security group, I want it to secure this resource. So all the rules I put on this security group applies to this resource. You can attach security group to the same resources and all. Now, this is another don't I'm going to be telling you. Best practice. Try to create security group for each resource. If you have resources that work together, like, okay, your database is together, like, okay, this is my database, I want this one, so you can try to put them together. But ideally, you want the security groups to be very configured, particular to what you are doing. This is, okay, in my web server, I want my web server to be I want my web server security group to allow access from my load balancer only. Everything else is blocked. Now I want my database to allow access from my web server only. Everything else is blocked. So no matter, even if all these things are in the same subnet, which they shouldn't be in the same subnet, even if all these things were in the same subnet, they wouldn't be able to communicate anyhow. It will be only in that direction that you allow. Like this one allows communication coming in from here, then this one allows communication coming in from here. It's a way to secure, it's a security group. It's a way to secure your resources. Now, I want to now discuss something with you. We've looked at security groups. We've seen that, there are inbound rules, there are outbound rules that we can set. This one allows all traffic in and out. Yes, it can be totally different from this. You specify, okay, I want this traffic to be allowed on this particular port, like port 22, port 3369. You mentioned the port database, port this, port that. You can specify which port you want to allow traffic in, or which port you want to allow traffic out. But the point is, be specific in your security group rules. Now we talk about security group rules. There's one thing that we didn't talk about in our subnets, which is the access control list. So a subnet has access control lists. We don't have a subnet here. I wish we had a subnet. I think I'll just create a subnet just for the sake of creating a subnet, so that we can look at it, because we need to look at it. You don't need to follow this. I just want to use it for demonstration. So the subnet, I'll just say, my subnet 1. I'll follow what they wrote there. My subnet 1. I'll specify the availability zone I want it to be in. It's going to be this. You can see this is based on my current region, which is EU Central 1. And I only have the options of EU Central 1A, 1B, 1C as availability zones. So I'm picking this, and I don't want to use my VPC CIDR block. If I use the same CIDR block as my VPC, do you know what that means? I'm assigning all the IP addresses I have in this VPC to this subnet. That means I can't create another subnet because I finished all the IP addresses. It's as if I have more IP addresses somewhere. But that's how you have to know what you are assigning for each subnet. You need to, okay, in this subnet, I want to deploy 3 databases, this, that, and then you say, okay, I need this amount of IP addresses. Of course, you give space, you allow more, and then you just go for the smallest that you can to assign to here. I used to go for like 24 for subnets, like /24. That's the mask. So if we use /24, I want to show you what that's going to be. /24, as you can see, is only 256 IP addresses out of our 65,000, meaning we still have a lot. So for this one, I would rather use 172.31.0.0/24. Okay. Oh yeah, I didn't even know there was something like this now in AWS. That when you type it, it will actually show you how many IP addresses, calculating it for you also. So you can increase it as you want. This is 26, 27 is also okay. I've also used /27. This is just 32 IP addresses. But the point is, you assign a sub number of your total IP addresses in your VPC to a subnet so that it will be available for use in that subnet. I'll go with /27, which is giving us only 32 IP addresses. And I'll create a subnet. Now we have the subnet. I just want us to really look at it in detail. Okay. So we have 32 IP addresses, and when you look at this, you see 27, right? This is something that is in networking. It's not only an AWS thing, but in networking, there are 5 IP addresses that are usually reserved. So whenever you count, you should also take note of the 5 IP addresses that are being reserved when you are counting. I saw 32, but you can see it's 27 that is actually available for me for my resources. Okay. And let me show you 5 IP addresses reserved by AWS. You can see them, they're here. So I wanted to show you. Yeah, these are the reserved IP addresses. Network address, there's another one that's reserved for the AWS VPC router. This one is reserved for some things. One is reserved. They are reserved basically. So you have 5 IP addresses always reserved. Calculate that whenever you're working with your IP addresses. And yes, back to what I was saying. The network access control list. So the route table here, you can see that the route table, we didn't specify any route table when we created our subnet, but the main route table in our VPC was associated with our subnet by default. Any subnet you create is going to take the route table of the main route table of your VPC. You can create more route tables and edit the route table association and create a route table and associate it. If you have more route tables, you change it and then it becomes that. But for now, we're going to just leave it at the main one. Now, the network access control list. Okay, let me see what's wrong with this network access control list. It's not loading. Okay, here it is now. This is the network access control list. This one is associated with a subnet. Remember, we were looking at security group, and they also add inbound rules and outbound rules. You wonder, okay, we have security groups that can have inbound rules, outbound rules. Why are we having network access control list that is also having inbound rules and outbound rules? Okay, so here it is. Remember, the security group is attached to an AWS resource. So I can attach this same security group to this resource that is in this subnet, attach that same security group to another one that's somewhere else, because like the same rules that I want to apply to them, it's as if you are attaching these rules to to the the resource. Like, how would I put it? This has nothing to do with the network the resource is in or anything like that. Whenever you're talking about guarding the network that the resource is in, you're going to be looking at your access control list, not your security group. Security group allows access to that particular resource. Now, the access control list allows access to this network at all. I don't want this traffic to get into this network at all. Or I want this traffic to get into this network. That's where the network access control is coming. We call it NACL. I call it NACL because they always write it abbreviated like that. But yes, your inbound rules, you set them here. Your outbound rules, you also set them here. Here, the rule number determines how it is prioritized. It determines the priority of your rules. Which one is more important or whatever. You can explicitly allow, explicitly deny your rules, your whatever rules you put here. You can say maybe, okay, this rule is going to allow this rule is going to deny this. You can deny everything by default. But in your security group, there's no option to deny something, or everything is basically denied by default unless you have a rule that allows it in your security group. I think I should open the security group in another page so that you'll be able to see it. You can see both of them, the access control list and the security groups. They are both under the security tab here. Yes, so they're basically for securing your environment, but they work differently. I want to emphasize that the network access control list is associated with a subnet. The security group is attached to a resource, to an Amazon resource that you deploy. So now, looking at this, you can see that we don't have any deny or allow here. We just have rules. And what it does is any rule you put here is basically saying that you want to allow this thing. Anything you put here is saying you are allowing it. So if I remove this here, that means I'm not allowing it. Everything I put here is saying I want to allow this, I want to allow this, I want to allow this. That's what it is. And another main thing you should know about security groups and your network access control list is this. Your security group is stateful while your access control list is stateless. Okay, let me see if it was mentioned here somewhere. Control network traffic. Okay, I'm guessing it's not explicitly explained here, but here I saw them mention it here also. So network access control list provides stateless network control, while security groups provide stateful control. But what that means is this: the security group knows it. When it says stateful, like it knows what came in. Let me open this for you. In your security group here, if I allow this traffic to come in, I don't need to go back to go and write an outbound rule to allow that traffic to go out again. If it was network access control list, I have to do that. I have to allow it in, and I also have to allow it out, because it doesn't know, it doesn't remember, it doesn't know what came in or what goes out. Or okay, you went in and now you're coming back out, and I'm like, I didn't see you before. Where's your permission to come out? you have to have permission to go in, and you also have to have permission to come out. Because if you go in with permission to go in, and not permission to come out, you're not going to come out. You're not going to come out. That's how the network access control list works. But the security group, you have one permission. If a permission says you can go in, by the time you are coming back, it's going to just tell you, oh, okay, I saw you before, you can pass. That's how it works. Now, I consider this one more versatile because you can easily attach it to specific resource within the same subnets. Like, okay, some resources are allowed to receive traffic from this part, from this other resource, or from this other group, but this other one is not allowed to receive it. You can do that with security group. But in your network access control list, everything in that same subnet, they get the same rules, they get the same access, they get the same denial. Okay? I think that's a good way to put it. And here we can say, okay, the main comparison between them is the first one, comparing the level of operation. It said, okay, the security group works on a per instance basis, attaching it to a particular resource. And the network access control list is on a subnet level. We already established that. The scope of the security group, it applies to every instance, every resource that we associate with that security group. If we associate it with this server, that server, everything we associate it with is going to have that. But if you are using only your network access control list, everything in the subnet gets the same rule. That's why you want to combine them, because your network access control list may not be as strict as you need it to be for a particular server. Okay, it's strict enough for your environment, but this server needs more particular strict watching. You need more. You do that with a security group. This rule type has only allow rules for security group. Remember, I said only allow in security group. There's no way you say deny. Everything is denied by default, and you put the rules that you want to allow. But in network access control list, you can put the rule to allow, and you can also put a rule to deny. And your security group evaluates all rules before deciding whether to evaluate traffic, whether to allow traffic. It checks everything before it decides whether to allow traffic. But your network access control list, it evaluates in ascending order until a match. You know, I said that priority. I was showing you in your subnet, like this one, you see the rule number that is there. The number you put will determine which layer, which level in your rule list is going to be, and that directly impacts whether that rule is respected or not. Because if it finds a match before it reaches there, Otilo, it has gone. It has entered. Yeah. So whenever you are using your network access control list, pay attention to your rule number, because if you have allow all traffic as your topmost and everything, and you whatever other rule you wanted to be checked before that would never get checked. It's just going to be allowing everything because it matches this one first. Okay, so be careful with the rule numbers and the order of your rules in your network access control list. And finally, this part of the stateful versus the stateless, the return traffic. Remember, I said security group is automatically allowing every traffic that comes in to go back out, or like as long as it's the same traffic going back, it's going to allow it. It's stateful. But your network access control list, you must explicitly allow it, because it doesn't take note of the packets, like, okay, this one has come in, when it's coming back out, I want to allow it to go back out. No. Network access control list requires allow in both lists, your inbound and your outbound rules, for it to work. Except if you don't want the traffic to return. That's fine. You put it only in one, and that's fine. Okay, so this is what it looks like. We talked about the region where our VPC is deployed. This VPC is in the region EU Central 1. Okay, And EU Central 1, we have availability zones. EU Central 1A, EU Central 1B, EU Central 1C. We are using only one availability zone here. And we have two subnets, a public subnet and a private subnet. A public subnet just means it's fully open with all the allowed rules. A private subnet is really close with all the network access control. And you have the security group that is attached to some particular EC2 instances. And you see the network access control list is connected with the subnets. So depending what is allowed here, it can go in, or what is not allowed, like that. We have the router and the internet gateway that connects to the internet. This router, well, we say router in this diagram, but look at it like using your route table to work. So it's the route tables that determine what the router does, okay? So I think we've touched everything in this architecture diagram. If there's anything in this architecture diagram that you did not understand, you can drop a comment in this chat, and I will make sure to clarify it in the recap that we are having. Now, to wrap up with everything we've discussed today, the security best practices. I'll just try to, they're not so much, to read through them quickly, and we'll go through them. So when you add subnets in your VPC, try to make sure it's in more than one availability zone. Mostly, you want to use 2 availability zones. You can go 3 if you really need it, but you want to use 2 availability zones. Like, okay, private subnet in EU Central 1A, private subnet in EU Central 1B, just for reliability. Use security groups to control traffic to the resources in your subnet. You have your network access control list, but you can only be very specific with your security group. Use your network access control list to control inbound and outbound traffic at the subnet level. Remember, security groups at your server level, your resource instance level, and then network access control list at your subnet level. You want to manage access to your AWS resources using IAM. We know IAM, that's the Identity and Access Manager in AWS. If you don't know it, you can check the series that we have. It's documented on the dev page, and we've gone deep into setting up IAM users and all that. The point is, you can restrict access to your resources by specifying which IAM users or IAM roles that you want to be able to access it, okay? You can do that in your policies, or basically you can restrict access using IAM. Now, there are VPC flow logs. We didn't talk about all of these ones, but I'm going to tell you what they do. You may need them later on, just know what they do. So you can enable VPC flow logs on your VPC, and it's going to be storing the logs of which traffics are going through your VPC. It's for monitoring. You may not need it because the more logs you store, it's costly, but depending on your use case, you can use VPC flow logs to monitor the traffic. Network Access Analyzer is to check what has access to resources in your VPC. So sometimes I use the Network Access Analyzer to try and see, okay, is this connection working? It's just to see what access works like to your VPC, to resources in your VPC, I mean. And then the network firewall. I don't know if you know what a firewall does, but firewall is basically filtering traffic in your environment. It's a network thing, but it's just like a security group is like a firewall, you get, but it's not a robust enough firewall that, you know, checks the IP address, packets, all these things. I mean, checks IP address, but it's not inspecting the packets that it's carrying and all. But I don't think AWS Network Firewall is even so robust. A lot of people still end up using third-party firewall and deploying it in AWS environment. But your network firewall is another level of security that you can enable for your VPC. So you use it to filter your inbound and outbound traffic and decide what you want to allow. And finally, using Amazon Guard Duty to detect potential threats in your environment. So these are like already built-in things that you can just take advantage of instead of trying to set up some security things in your environment. The basic threats and all that are already able to be detected by these services. That brings us to the end of today's stream, brings us to the end of today's session. Thank you for joining. Thank you for spending time. I look forward to seeing you again next week. Have a nice evening. Bye bye.